Hey, this video is about strong acids and strong bases, and we're going to look at pH and titrations and lots of good stuff. All right, so first of all, you need to know your 7 strong acids, and we've talked about those a lot this year. What we're adding to that now is that you know that their Ka value is very, very large, which means that when you put them in water, the equilibrium lies far to the right, so lots and lots of products, which essentially means that they have ionized in water or dissociated in water. And so if you had, say, 0.01 molar hydrochloric acid in water, that proton concentration would be 0.01 molar. And so now you can get a pH easily. So the concentration of that acid equals the concentration of the protons in solution. Take the negative log of it and you'll get the pH. Bases, also, we've talked a lot about that. It's any soluble salt that has a hydroxide ion in solution. And so like 0.01 molar sodium hydroxide, the hydroxide ion concentration would be 0.01. If you took the negative log of that, you'd get the POH, subtract it from 14, and you'd have the pH. This is all review. The only thing that you really need to be careful of with these strong bases is when you have something like calcium hydroxide or barium hydroxide, because the hydroxide ion concentration will be twice the molar concentration of the solution because of that 2, that subscript 2 after the hydroxide. So if you had 0.01 molar barium hydroxide, the hydroxide concentration would be 0.02 molar, and then you would go from there to get your pH. All right, so that's all review. But now let's talk about a reaction between a strong acid and a strong base. So we're looking at hydrochloric acid and sodium hydroxide. It forms sodium chloride and water. Sometimes these reactions are called neutralization reactions because when the base is added to the acid, what do you make? Sodium chloride. And from our video about the pH of salt solutions, we know that the pH of sodium chloride is neutral because chloride is the conjugate base of a strong acid, which is weaker than water, and sodium ion doesn't affect the pH. And so when you add a strong acid and a strong base together, you're going to get a salt and water, and it is not going to change the pH. So it's a neutralization reaction. I shouldn't have said it's not going to change the pH. The pH is going to be neutral when you have equal amounts of both, and we're going to talk about that later. The net ionic equation for these reactions are protons plus hydroxide ions yielding water. Now there's something called an equivalence point, and that is when the moles of the acid equals moles of the base. So moles is equal to moles. So we know that molarity times volume equals moles, and so this statement down here, MAVA is equal to MBVP, is for the equivalence point, where the moles of acid equals the moles of base. The only thing we have to be careful of is if we had something like that barium hydroxide, where you had 2 hydroxide ions, or if we had a diprotic acid where you would have more than 1 proton. And so we kind of have to modify this just a bit and make sure that we include the number of protons that are on our acid or the number of hydroxide ions in your base. So anyway, let's practice using this formula. All right, so this is what a typical problem would look like. What is the volume of 0.115 molar per chloric acid, I have no idea why you'd be using that, is needed to neutralize 50 milliliters of 0.0875 molar sodium hydroxide. There's that word neutralize. That means that you are going to add equal moles of the base so that the pH of the solution would be neutral. So in other words, we're at our equivalence point. Our moles of our acid will equal our moles of our base. This acid has 1 proton, so we don't have to worry about putting like a coefficient out in front of the molarity of our acid, volume of our acid, and we only have 1 hydroxide. So we just plug these values in. We solve for our volume of acid. I'm keeping my volume in milliliters on both sides, and so my volume of my acid is 38.0 milliliters. So here's another practice problem. What is the molarity of calcium hydroxide? And there's the formula. Remember, you have 2 hydroxides because calcium is plus 2. If it takes 48.8 milliliters of 0.05 molar hydrobromic acid to neutralize 100 mils of that calcium hydroxide solution. So here we have the volume and the molarity of our acid. So we just went ahead and plugged those in. It's a monoprotic acid, so just a 1 out front. For the calcium hydroxide, we're looking for the molarity of that concentrate of that solution. We have 100 milliliters of it, and remember we have 2 hydroxides there that need to be neutralized, so we put a 2 out front. When we solve for the molarity of our base, we get 0.0122 molar. So I know we did these in standard chem, but I thought it might be worth just a short review on this. But continue on to the next video where we look at titrations.